Welcome to Mavens of Data. This week we're speaking with Vin Vashishta, CEO of V Squared. Here he covered why project management skills are increasingly important for senior data scientists, why role inflation and poor leadership are risk factors to watch for in companies, and why the gap between discovering insights and delivering value is a critical growth area. Hope you enjoy this episode. Vin, thank you so much for joining.
Oh, thanks for having me. Really appreciate the opportunity to be on, talk to everybody here today.
All right, awesome. And I actually never say this ahead of time, but if you are not currently following Vin on LinkedIn, you need to go do that. I know, don't get embarrassed or feel weird, but honestly, he posts some of the best LinkedIn content around what businesses are up to in the AI space. I have learned so much. It helps me learn a little bit more about business in a way that I might have not seen previously. And you know, it's all authentic, regular, consistent content. So he is one to follow for sure. And so Vin, in your own words, for people who might not know you, can you give us a little background?
Started in technology almost 30 years ago, which means I'm old, and I've seen now 4 different hype cycles going through .com, cloud, big data, and now AI. And it's interesting, they all follow the same sort of trajectories, but they all have their differences. I started a company when I was in college, went about as badly as it could go, but ended up selling it, went into the corporate world for about 10 years. I've done everything from software engineering to data science, founded V Squared in 2012. We were originally services and an R&D, research and development consulting company, helped Fortune 100 clients. Our first client was Siemens, and kind of took off from there, working on supply chain. But we've worked in finance, retail, you name it, we have done it. What we figured out in about 2016, 2017 was that companies weren't getting returns, ROI, from their data, AI, analytics, whatever initiatives. So we pivoted a bit and we started focusing on product strategy and connecting technology with the business. And that's what we've been working on now for almost 9 years. Started teaching in 2017 and 2018 as well. Have a whole series of courses that I offer that help anyone in the technology realm figure out the business. Everything from just basic value-centric data science all the way out to product management, AI strategy, leadership, because that's the most underrated skill that we have right now, is people that are both technical and able to support the business. It's what I built V Squared on top of, and now I teach it. And I got to say, teaching is a lot of fun.
Oh my God, it is so much fun, right?
Yep.
Okay, so hype cycles, we're in the middle of this huge AI hype cycle. The most recent buzzword, it's not a buzzword, it's real, but well, we're going to get your thoughts, is Agentic AI. So for everyone who's here, you just explain what the difference is between, you know, the LLMs that we're seeing, Agentic AI, and maybe, you know, how that's also different. I feel like the definition of AI is really hard to place right now, but, you know, at least the difference between LLMs and Agentic AI, so everyone has a very clear understanding of the difference.
Yeah, definitely. LLMs are the model. So that's the foundational model. That is the learning within a language domain. But language is a pretty broad thing, right? And this is something Jensen Huang's pointed out repeatedly, is that language isn't just our spoken languages like English and Japanese and French and German. It is language as in biology is a language. Genetics is a language. You can say images have their own language. Business has its own language. So LLMs are the foundational model that learns a domain, and it learns to predict the next token in a domain. So that's your LLM. That's a big model that figures out how to communicate in a particular domain, whether that's predicting a genetic sequence to predicting, you know, some sort of funny haiku, or predicting the next pixel in a cat video. So there's a lot of different use cases for LLMs and foundational models, but agentic systems are a little bit different. Agentic systems have this construct of agency, meaning they can take action. And it's not just any old action. It is an action that drives some outcome, something valuable, either for an individual consumer or for a business, maybe even for another model. And agents aren't simply a single model with a couple of wrappers around them. Agents handle these nice, long, high-value workflows. And when you do that, you need tools. You need access to data sources. You need all sorts of additional components, kind of creating an ecosystem that augment and enable your capabilities to act in that agency component. So when you think of an agent, don't just think of a model. Think of something with the ability to act and do things that are valuable for us, not just generate, but do real work.
Okay, so you're saying, right, when we think about the like textbook definition of AI, or if I looked in Merriam-Webster's dictionary, right, so non-technical, it's going to tell me that it is, doing something that a human used to do that's now able to be done by a computer, right? And so a logistic regression model outputs a probability, and I say if a probability is greater than 0.85, do this, versus, if it's less than 0.85, do that. So agentic AI has to be more complex than just getting an output from a model and doing something on top of it.
Right. But I think you bring up a really, really good point, which is when you talk about software, you're talking about something that's very rules-based, something that's very logical. But when you begin to introduce models, especially LLMs, now you're talking about something that's probabilistic, something that's stochastic. And you can handle an entirely different type of workflow, right? Mm-hmm. You can now bring forward the capability of supporting things that don't have one solid answer, or that deal with a whole lot more than you could represent in your, if else, or your conditional loops and statements. So now you have something that it doesn't think, it's not, intelligence, the way you were talking about, with the textbook definition of intelligence or reasoning, but it does some very simplistic reasoning. It does have some level of thought that's happening behind the scenes, and it can handle higher uncertainty. So we can support so many new workflows with agents that we couldn't support. And it's really just back to that traditional model paradigm, where it doesn't have to have a black or white, 1 or 0 answer. Mm-hmm. It can have something that's like 85% of the time, this is going to be the right thing to do. So that's what I'm going to try first.
Mm-hmm. Awesome. And so now with these agents, how do you see that changing the role of the analyst specifically?
Well, you look at agency, the ability to take action, the ability to support sort of these fuzzier workflows, ones that you wouldn't be able to write business logic around because, users don't necessarily understand those needs well enough to document them in a way that you could put into code. Mm-hmm. Sometimes they're reliant on really, really large data sets. So if that feels like it's encroaching on data analysts' territory, being able to access data sources and providing visualizations, some LLMs are really good at that. And when you put agents around them, you give them access to data, you give them the ability to act and be proactive. Now, all of a sudden, it feels like those are sort of encroaching on the data analyst, data engineering, in some cases, territory, because it can write really simple notebooks on its own. It can create its own visualizations. It can access data sources. It can work in collaboration with other apps, other platforms. It can get data from multiple sources. Sort of feels like that's beginning to encroach on the data analyst's territory. It's listening to users and creating solutions in a way that data analysts are really used to doing. So we're seeing a lot of the heavy lifting for what data analysts used to do for the business now sort of being represented as there are these apps and these platforms now that are going to take it over, with a huge if, which is when you start using these things, I mean, how well do they work?
Mm-hmm.
Some of them are good. I've worked with some, semi self-service analytics solutions that are really, really high quality, but it's the gaps. And so if we ask, where are we going from a data analyst standpoint? Where is the field going to go? It's filling in these gaps. The things that LLMs and agentic systems are bad at. One of those is the LLM isn't going to organize your data for you. And data engineering really focuses on, okay, let's clean it, let's move it from one place to the other. But data analysts do something that's richer, something that's more valuable, which is, how do I structure information? How do I turn this raw data into information that can be used, that can target decisions, that can be used to train other models? How do we deliver products? And that's, data analysts are all about that data product, and even in some cases model products.
Mm-hmm.
And LLMs, even agents, not necessarily great at that side of it. So it's now less of the grunt work and the drudgery components of the data analyst role, and more of the, how do I structure information? How do I turn this into a product, something that's going to create value for the business, or just for one-on-one, this user? Because LLMs don't do a great job of that. Agents are an improvement on it because they have more agency. They can take more actions, but not all of those actions are the right ones to take. Not all of the data products that they deliver are exactly fitted to the need. So data analysts still have a lot of value, but the direction that you're going in, you're still definitely using and leveraging technical skills, but it's more of your understanding of information architecture and how to turn information into value, that productization. Those pieces are more important than ever.
Oh, and just to call out too, Vin has a book, Data to Profit, and that is sort of a big piece of what he really likes to talk about is, how do you take data and create value from that? He's like an expert in that topic.
Well, thank you. I appreciate the book plug.
You're welcome. So I've also seen, I was at the Salesforce TDX conference last week, and I was able to build a demo of an agent using, a point and click UI. Where do you see the building of these agents sitting within an organization? And is there a chance that analysts could be the people building agents where it might require some technical understanding? It doesn't require an MLE. It doesn't require a software engineer. I mean, it does for fancier things, but for the types of things that could be built with more of like a point and click tool, is there a chance that'll land with analysts?
Yes. And interestingly enough, I talked to the chief product officer for Tableau, and he looks at not only data analysts, but also BI engineers, turning more into, instead of data analysts, information analysts and information architects. BI engineers are really turning into knowledge graph engineers and ontology engineers. Mm-hmm. So these two roles, it's not like they disappear. You're just taking data and putting it into the hands of these agentic systems. You're now moving them into the information. Information is value. And the difference between data and information, data is just the raw data points that you're used to working with. Information's contextual. So it has context about whatever it is that generated it. What's the system that created this data? What was, potentially, is it a user? Is it a customer operating the website? Are they navigating around trying to find a product? What were they looking for? Did they find it? What happened when they found it? Did they buy something? Did they buy multiple? So all of these pieces of context turn data points into information because it makes them actionable. That's more of where data analysts and BI engineers are going. But part of that, what you're alluding to is, okay, now that we have these information products, information's critical for agentic systems. If you give them access to just data, they oftentimes go off the rails. And we're seeing some RAG strategies are very successful, other RAG strategies where you're just throwing them at a vector DB or you're throwing them at raw data, yeah, that doesn't do very much. You're not seeing improvements in reliability. You're not seeing any sort of managing of hallucination issues. So the right people to create some of these agentic systems are data analysts,
Yeah.
really information analysts now, working hand in hand with users. And in my agentic architecture paradigm, level 3 is a co-development environment where you have, on one side, you have to have some technical resource, but that technical resource has to be very business centric. They have to have some level of domain expertise so that they can relate with the problems and bring that domain expertise into the solution, into your agentic architecture, designing things like guardrails, giving access to the right APIs, the right apps, creating sort of these intents are inbound. You can serve these intents. These other intents that users may bring to you, you really shouldn't serve them. So you're hearing it's not just a technical solution. It's really this co-development between users and this data and information analyst who's not just curating information resources, but also making them into a new type of product, which are these agents, and providing information as a tool to these agents, but also empowering frontline users to be able to be part of creating these solutions for themselves. Obviously, you don't want to let them go wild on day one, but the goal is to educate and to make them more capable of delivering and managing their own solutions.
Yeah. And when you talk about, the idea that you have to have some level of technical expertise, you need to understand how you may need to use this API, whatever, plus having the business acumen, like, to me, it really sounds like something that could end up sitting, in our house,
Yeah.
in the analytics house.
Yeah, I mean, you see the models themselves are becoming more commoditized, but the products that leverage the models definitely aren't.
No, oh my God, it's been wild to me watching over the last 15 years, manually fitting a model, and now it's just like, model.fit, boom, and
Done.
it's a different world. And so what types can you share some real life applications of agents that you've seen?
So I have to be a little careful. I have to be a little careful when it comes to NDAs.
Of course.
But marketing is really a powerful use case. I like marketing a lot because there's a behavioral component to it. So personalization is huge. And that's one area where agents excel, is they're able to personalize at scale in a way that marketing teams couldn't do in the past. So something as simple as a little chat agent in the corner. People are sort of accustomed to ignoring those because they're useless. Let's be honest. The majority of chat interfaces that pop up on websites and say, hey, I'd love to help you, it's like Clippy. You look at it and you go, no, you're not going to help. You may think you're here to help, but you're not going to. With agents, what we're able to do is bring in, as part of the prompt, so much additional information, not only about the customer, but what the customer's been doing for the last 5-10 minutes on the website. So with this 360 view, you can add that into the prompt, and now the LLM doesn't have to ask all of those canned questions over and over again. If somebody shows up on your website once a month to reorder a specific thing, especially, I mean, I see this in pharmaceuticals or pharmacies, retail, you're just reordering the same prescriptions every month. If it's the day that you normally come in and reorder a prescription, that chatbot should know that. It should just say, oh, hey, let me help you reorder that prescription. That's what should show up in the corner. So there are places where we can see significant value. Why? Because that person's not going to have to call in and take up the time of a pharmacist or a pharmacy tech. Those people can now do a higher end job than answering the phone and doing very simple prescription entry. And it's just data entry. That's all it is. And if you have this little thing on the side of the website that just says, hey, are you here to reorder these 3 prescriptions? Yes. Awesome. Thanks. It's all set. You're good. Here's when it'll be ready. Those are the types of use cases with significant value because you have limited, finite human resources doing very, very simplistic, repetitive tasks. Agentic systems also very good at orchestration. When you look at more complex applications, and I'm not throwing shade, but I'm just saying SAP may be sort of a complex platform to use. It may not be known for being the easiest thing in the world to leverage, because to get one thing done, sometimes you're going to 15, 16 different apps to complete one single workflow. What happens if you put one single front-end interface as the single touch point to a more complex back-end system? Well, you've just dropped the learning curve significantly. Now I don't need to know where to go. I just have to tell you, this is what I need to get done, and you can walk me through it. Orchestration is huge, where the LLM, all it does, and all the agents are, is really the apps that were always there with the models that were always there and the data sources that were always there. But I don't need to know all the different places to go and all the different steps that I have to complete and all the different, I can just ask. And agency, this agent that I'm chatting with, now has the capability to help guide me through this. So instead of having to have this massive training sort of ramp up time in order to get anyone to be able to use this version, let alone, the next version that we're coming out with next year and the one that comes out a year after that, instead of this being a continuous and constant learning curve, all I have to do is interact with this single interface and know what it is that I need to get done, and it will handle orchestrating all of the complexity on the back end. That's another huge, where you can really avoid the complexity, and you can build more complex back end systems now. You don't have to worry about, this would be a nightmare of spaghetti because we have 85 different apps that they would have to go at, and 38 different data sources. Now the user doesn't care. So yeah, we can make it as complex in the back end as we need to without worrying about the user interface, because the user interface is a single agent that interfaces with this agentic system and orchestrates all the resources, whether it's an app, whether it's another model, whether it's a report, whether it's a data source, whether it's getting data from us that we didn't know we needed to provide. We can now facilitate simplicity even in complex systems. So that's another really big agentic use case scenario. Any place you have these longer chain workflows, and it would be nice to have something that just knew what you needed it to do, knew your outcome or objective, so that you didn't have to say, do this, do this, do this, do this, or yourself hop from 5 different apps to figure out one thing that you need to do. That is a huge use case, just that orchestration component. So we think about these things in terms of, it's a model, it lives by itself, it has to use its own internal knowledge graph to answer all of these questions, and that's absolutely the wrong way to be thinking about these things.
Mm-hmm. Wow. And I think the biggest one that stood out to me was the personalization that you mentioned, because you talked about how it's going to make things easier for the customer, but really businesses have been trying to figure this out for the last 15 years, because the bigger, sexier companies, the Amazon, they already sort of figured a lot of it out, and they're giving personalized recommendations. And yeah, it may not have been awesome, but people got a taste of that. And so they can't go to a website and have it not recognize that you are a returning customer who has taken some actions there and treat you like somebody they don't know. Because now, for years, it's turned customers off. But at the same time, companies haven't really had the infrastructure set up to be able to tackle that problem effectively. They've been thinking about it. They've really wanted it. They've thrown some resources at it, but they haven't really been effective.
Well, yeah, our recommendation systems are good on the back end, but sometimes lacking on the front end. Yeah, yep. Definitely.
Okay, so with all of this going on, what can analysts here assume are things that aren't going to change as a result of agentic AI?
Well, I think sort of a dual answer. I'll answer the question you're not asking and answer the question that you are at the same time. Most people are wondering, does coding go away? Will software engineers evaporate off the face of the earth? I think it's important to realize that the amount of time you spend coding will go down, but understanding your patterns, best practices, how do you code, really software engineering, systems design principles, all of the things that are really that top level architectural complexity and engineering solutions design complexity, those aren't going away. You're still going to need to articulate and be able to validate. But the amount of time you spend writing SQL will plummet, especially over the next 2 years. You'll see the amount of time you spend writing SQL plummet. And that'll give some people the impression that you don't really need to understand it, which is wrong. You still need to understand the fundamentals and the foundations, but the amount of time you spend doing it yourself will come down. You will increasingly be designing the most complex parts of the solution versus all of it. You'll be really learning to prompt and learning to interact with agentic systems, coding tools. So that's where if you're learning or if you're trying to adapt your career, technical is going to mean something very, very different, really, by the end of this year and next year. We're not talking about 5 years from now. We're talking 6 months from now, where the meaning of technical is, can I deliver a comprehensive solution that meets a customer need, that meets a business need, and that's creating value for the business. So it's not just about technology. You have to be technical and technical and a domain expert, something we talked about a little bit earlier. If you understand the domain, your solution is so much more comprehensive. Technical, and we're seeing a lot of product managers who code, where they understand not just how to build, they understand what to build and why they should build it. They have all of the processes required to go out and figure out what we should be building. And they have this rich understanding of things like pricing, opportunity size estimation. Those are really critical skills for technical ICs to begin to develop, because now the business looks at you not as a tactical thing. You show up and write the code I tell you to write, but I've got to give you these really detailed instructions in order to be able to get value out of you. You want to become someone that, especially C-level leaders, see as being capable of managing and owning their own value creation. So it's more than just writing SQL statements. It's more than just writing some Java or some Python. Java's better. It's...
No.
Get it? See, being old's kind of cool because I can get away with saying stuff like that. But it means more than simply delivering code. It means delivering products and solutions. It means delivering something that generates value, that generates an outcome. And it means partnering with technology, partnering with these agentic systems and platforms and tools so that we can deliver value. It's also about simplifying the technology and creating tools and frameworks for non-technical users so that they can pick those things up and manage some of their own technology needs. They won't be able to just vibe code with the LLM and get some sort of massive reporting solution that's reliable and it's awesome. Yeah, that's not coming.
Yeah.
But the really valuable people are the ones who can create this tools ecosystem for them. So that co-development environment that I was talking about earlier. Really valuable people can create the frameworks that they'll just sort of pick and choose and customize from that part of the agentic system. And they'll be able to deliver value as a non-technical developer because you've put all these tools in place, but also because just like you're validating the LLMs solution and the agentic systems solutions, you're also validating these non-developer solutions. So you're always doing a whole lot of these code reviews and solutions reviews to ensure that what's getting built does what everyone needs it to do. And you're doing a whole lot of, air traffic control where you say, nope, no, that's no, that was almost a disaster. Let me fix this one thing right here. And you become more of a value-centric technologist and a product-centric technologist, building out things like information resources so that you're helping the business deliver, basically turn technology into value, turn it into revenue and growth, because that's what CEOs need. CEOs are dropping like flies. And they really are. We have lost more CEOs in the last, I think it's 14 months now, than at any other time since 2002.
Whoa.
Yeah, CEOs have some, let's say, job security concerns. And if you become a strategic lever, somebody that they're used to calling up with, hey, I've got this problem, you become one of the most valuable people in the business.
Mm-hmm. Well, and speaking of those problems too, right? You're talking about the value creation, but at the same time, the biggest thing that I think of when I hear people saying that, like, you know, we're only going to need junior developers because the coding's so good. No, we're not. Like, when your legacy code system has a problem, we need the person who can go in there and in a short amount of time get this back up and running, because they understand what's going on with that system and know where to look and how to fix it. I get really
I think it's also important to realize that, you know, companies that can't transform rapidly are not going to survive. Mm-hmm. We're watching, I mean, look at what's happening in retail right now. Retail is getting punished for...
Joanne Fabrics is going out, and I'm sad.
Oh, no. I mean, we're losing a lot of different companies. Yeah. And it's really because growth now is driven primarily by online. Mm-hmm. Growth is driven by hyper-personalization, by creating experiences that differentiate brands. That's where growth is coming from. You can't do any of that without data analytics, AI. So the companies that can't turn their legacy systems into something more mature, I mean, Southwest Airlines is going to be the canary in the coal mine for the airline industry. And we'll just see example after example after example in every single industry where a company really lived and died by its technical debt.
Mm. And so shifting a little bit to how we store our data, comparing vector databases and graph databases, I know you're a graph guy. I would love to hear why you think that that is the best way to go when you're building these types of systems.
I'm going to get a little nerdy here, but I think it's worth getting into. When you create a vector, you lose information. Yep. That's the challenge. If there was some transparency layer where it was easy to understand what information was lost and an easy way to correct it when problems happened, vectors would be a great solution. Mm-hmm. But they don't work because you don't have either one of those things. You don't understand what information was captured in the vector, what information was lost, and you don't have a way of fixing it. So you sort of have to test in production to figure out where all your problems are in your vector representation. So very, very important to understand that vectors for search, yeah, you can definitely simplify and optimize. The problem is you lose so much information that the cost of those optimizations is very difficult to quantify and nearly impossible, really infeasible to fix. If you represent information in a graph structure, you have a much richer representation. And one of the most successful approaches to RAG uses knowledge graphs and in a more formalized setting an ontology. Although in a business setting, it's really tough to do formalized ontologies. And that's sort of why we talk about knowledge graphs. They're this middle ground. An ontology is assumed to be complete and it is rigorously engineered. Raise your hand if you have enough time to do that. Raise your hand if you have enough, user buy-in that they will show up for 3 months worth of meetings once a week to review and, sort of dump all of their domain expertise to you in a way that you can engineer. Yeah, I've never found that company. I'll let you know when I do. Mm-hmm. You have to have sort of a rational approach to creating ontologies. And so knowledge graphs make a very compelling middle ground. What you also find is that LLMs are good at creating these seed ontologies. where it's essentially the high-level framework for a knowledge domain that you can build on top of and take to users. And instead of asking them, hey, fill in everything, you can just say, here's what I came up with on my own. Where do you see the gaps? Where do you see the inaccuracies? And I'll fill it in and start adding it in from there. You also realize that experiment management, as you run experiments and curate new data sets, a lot of these new data sets fill in parts of the ontology or the knowledge graph that even domain experts didn't catch.
Mm-hmm.
Even domain experts may be surprised by some of the findings, some of the relationships that you learn. And knowledge graphs are really cheat codes for more complex models. If you can use a knowledge graph as an input layer, really what you're doing is you're fast forwarding that model's learning of the context, the relationships between all of these features that you're throwing at it. Instead of telling it, hey, you figure out the relationships between these features, you're giving it sort of this structure. It's a symbolic I know that's a bad word. Symbolic
Mm-hmm.
representation. Please, nobody flamethrower me for using the word symbolic, but it is a representation of the structure and relationships of the data. So the model doesn't have to relearn everything from scratch. It has a primer that explains what are the relationships between all these features. And it can use that as its starting point to learn from. And you can use much, much simpler architectures. And you also get much more reliable models. But you also know when something's going to need to be retrained. Because if you see a change to your knowledge graph structure, that probably indicates that the model that trained it might need to be reevaluated. So now you're in front of problems. Instead of finding out that the model is misbehaving in production, you see this happen before the model starts getting unpredictable. And it's really important to have these knowledge graphs. When you talk about what does a data analyst do, I mean, if that kind of sounds like your job already, but you're just doing it ad hoc, you're building these knowledge graphs into reports and into data products. So if that sort of sounds like what you're already doing, you are in many ways an informal information architect. I often say there's a lot of people that end up being accidental product managers, where you get forced into figuring out how to make money with this thing. Well, a lot of people also get forced into being information architects because it's an optimal structure. The graph represents the business better. Well, I mean, unless your business is, some sort of N cube. I've never seen an N cube business before, but maybe there is one out there. But nothing is that structured. Graphs are such a better geometric representation of your business because your business is complex.
Mm-hmm.
And when you have not just the data points, but also sort of the purpose of data catalogs really is to explain the interconnectedness between them. When you have that in a single knowledge structure, easier to manage, and that information can now be used by anyone. You don't need to bring your own domain expertise. You can be someone who's outside of the domain, but they can still use this information product because it has the context required for even non-domain experts to use that information.
Wow. I really loved what you said, and I have sat in ontology meetings and they were very painful, and it almost feels like the same problem that we've always had, right? Where the business says, I believe it's this, my gut says it's this, and really it's like the next level, because it's not that people haven't been looking at the data, it's that if you looked at the graph data, you'd see more complex relationships that you weren't picking up using relational tables, right? And the barrier to entry is actually pretty low on this because you don't actually have to go and set up a full graph database. You can use something like Node Excel, throw your data at it and say, wow, am I seeing any relationships that I didn't believe were true? Am I seeing anything new here?
Yep. And it's, the power of it is when you kind of getting into the causal side of this as well. When you look at a knowledge graph and a structural causal model next to each other, you begin to just kind of go,
are they cousins?
I'm seeing similarities. And that's where you're going. If you think about what would be the most reliable model you could train versus what is the most complete knowledge graph that you could assemble, or most complete ontology, you begin to realize, wow, these are really similar, and there's so much overlap between the two that building models from a knowledge graph is so much simpler. But the thing I love to use knowledge graphs and structural causal models for is presenting them to users, because you are now representing it in a way that's completely accessible to a non-technical audience.
Yeah.
They look at it and they go, that's wrong. So just like what you said, sometimes you look at this and you say, well, does that look right? Does that look wrong? Instead of trying to explain your model in 50 different ways, if you show them either the knowledge graph, the ontology, the structural causal model, whatever it is, if you visualize that in front of them and you say, what do you think? They'll go, wow, I didn't know that.
Mm-hmm.
Oh, wow, that's really, that right here, that's completely 100% spot on. I don't know what that is. That, on the other hand, doesn't make any sense. You should probably look at that one because maybe you got a problem. And you can have a user with no technical or data science background at all, just a domain expert, start talking to you about things that you can then immediately use to improve your models or to improve your data products. And it's a conversation that they love to have because you're emphasizing their expertise, not the models. And when you put people at the center and you make them feel like experts, that's what builds credibility. That's what builds trust. When you can show it to them in a graph, and I've done this before with users, the most complex models, if I can represent it as a graph, we can talk through why it does what it does. And so now we're not talking about the model or the math or any of the feature complexity. They're just saying, hey, how does it use this data point? And I can go, well, okay, so here's the relationship region. Here's the region of the graph that defines these data points and the relationships between them. And I get the best feedback from experts who go, yeah, no, that totally makes sense now. Okay, I see why it did that. Oh, that makes sense. And they trust your model more just because they've visually seen some parts of the inner workings. They don't have to see the whole thing. Like, you don't have to go to SHAP complexity here. But you can show them sort of the relationships and why the model does what it does and why it thinks the way it does. And it's such a richer conversation than trying to decompose the model output and then tie it back to the inputs. And if you're looking at it visually, it's so much cleaner.
Okay. So now it really is time to go over to Q&A. So if people have questions, make sure to post them now. But Vin, if you had to, for the analyst, if you were going to tell them to study up on like one or two things, sort of looking across everything, what would your suggestion be? Not necessarily the new analyst that still has, but the person who's gotten there.
Yeah, information architecture, information sciences, even getting into some decision science and understanding behaviorally why people make the decisions that they make. How can you introduce data products, information products, models into their decision workflow? How do you map a decision chain? Understanding these components, everything from information sciences, information architecture, really understand the rigorous component of ontology engineering, but go back and just make everything more pragmatic, because the scientific approach to ontology engineering will not work in your business. It just won't. So think about things in terms of, it doesn't have to be perfect. It doesn't have to be complete. It has to be better than what the business had before, and it has to drive a better outcome. It has to introduce more value. So just really fundamentals, first principles of knowledge graphs, information sciences, understanding what it means to gather data contextually. So you can hear, I'm talking about being technical, but I'm talking about being technical in a very different way.
Savvy.
Than you're used to it. You're used to, code equals technical sophistication. What have you scaled? Have you been able to work with 300 terabytes of data? Are you working with streaming? No, that's not what being technical means anymore. Being technical now means more of that information architecture. And so that's where I would go first, really dig into information architecture, information sciences.
I love that. And that's the first time I've heard that as an answer too. I love it. Are you ready to answer some questions?
Oh, yeah.
From Dom, when applying to data analyst roles, how can I ascertain if a company has or is working toward an AI-focused data strategy? What questions should I ask?
The first thing that's important to understand is that your data strategy is your AI strategy, because no data, no AI. So you want to ask questions to figure out if they've come to understand that or not. Very important to ask, how does your data strategy amplify your AI strategy, and vice versa? More times than not, what you want to be listening for is tactics. If they say strategy and then they say, well, we're hiring and we're re-architecting the team and we're using these, these technology components and these infrastructure components, or that's not a strategy. Those are all tactics. You have to ask, where's the value coming from? So from a data perspective, how does data generate ROI? Most companies will not be able to answer that question. There are CDOs. I think this last study that I saw from Gartner was something like 70% of CDOs cannot answer that question. How do you monetize data? How do you measure the value of your data? So it's more important that they understand that that's a gap and they're working towards it. Very few companies have a rigorous AI strategy that's aligned with their data strategy. So sometimes it's also important to figure out, do they know that's a problem? And then also ask, where do you see me helping you to connect the dots between your data strategy and your AI strategy? How do you see this role being involved in data monetization? How do you see this role being involved in implementing the data strategy? So really good questions to ask. You will often find that companies haven't figured this out, but that doesn't mean they're not working on it. And that may be one of the reasons why they decide to hire you.
Mm-hmm. And being part of that data monetization is your job security.
Oh, yeah.
End.
Oh, yeah.
End. Period. End.
Oh, yeah. I've made a pretty good, pretty lucrative company out of that.
All right. Let's see. This is Carlos. Can you provide insight into the role of data lineage and the establishment of baselines and measuring performance and innovation related to AI and the emerging role of the digital logistician?
I don't know if I can speak to digital logistician very well, because we're getting kind of into the weeds with that one. But it's a really good question. When you talk about lineage, if you don't understand sort of that context, what was the system that generated the data? Why was this data, what was the person doing when they generated this data? Who generated this data? What workflow is it attached to? What was the objective that they had coming in? What was the outcome they achieved? If you're not measuring at least with that basic context, and that's really where data lineage is going. It's not so much just having a chain of custody, but having all of that more complex metadata and contextual data around it to deliver information and information product. So that part of it is extraordinarily critical. And baselining is really that connection to, when you start talking about knowledge graphs, we talk about the connection between data points, but it's also a connection to outcomes. If I'm a customer coming onto a website and I'm looking for a specific product, did I find it? That's a huge and important connection to an outcome. And you want to see what's the baseline for our current search. When people come in and they show up to the website, they run a search. How often does that search lead to a product that they click on? How often does that click lead to a sale? How often do they have to click on multiple products? How far down do they have to scroll? So you can hear there's a lot of contextual data. And if you have a baseline, now you can say, I have a hypothesis that if we introduce this new information, this new model, this new AI, this new agent, if we introduce this, I expect this improvement to happen. And now that you have a baseline, you can then prove ROI. because we've introduced this improvement into the workflow. Here was our original baseline. Here's the way that it's the outcomes that we're seeing now. So this delta is the ROI.
Perfect. And then we just got a new question in, and I've honestly been thinking the same thing myself. How do you see the morphing of software product managers into AI-infused product managers versus data science ICs transforming into AI product managers? Who is better suited? What could be the skill gap, and how can one articulate them to companies hiring for the role? I honestly could have asked this question myself.
It's a really good question.
Really good.
I think it's first important to understand the difference. You have software, digital technology that's monetized in one way. It's not like software is going away. It's not like apps and APIs and all of that disappear and poof, we're done. Everything's AI. That's not how it's going to work. We've already talked about the agentic ecosystem, including apps, APIs, digital technology, cloud. So we're going to have a multi-technology environment. So software product managers and digital product managers are still going to manage software, which is monetized one way. And its cost structure is also very different. When you look at data analytics, machine learning, it's a completely different monetization model. Your model can handle deterministic and stochastic workflows. Should it handle a deterministic workflow? No, because software, right? It can do that too, and software is cheaper. Models are more expensive. They're also more unpredictable. So if you need certainty, so you can hear there's differences, right? We have to train these new paradigms. It's pricing, it's monetization, it's how they're built, how they're made. How do you create a roadmap that goes from data to analytics to machine learning to deep learning to AI? How do you integrate into an existing platform, and how do you start to build an AI first platform? How do you morph this into a multi-agent platform? All of these questions are in the wheelhouse of your data and AI product manager. So we need to teach a completely different monetization model. And I think data scientists and technical ICs on the data space, especially data analysts, data engineers as well, morphing into product managers is a really powerful paradigm. It's one of the reasons why I teach really targeting technical ICs, because I think this is one great way to extend your career. But it's also all of that technical knowledge and expertise. When you add an understanding of monetization, an understanding of strategy, you become extremely powerful, because data and AI are the first technologies that can support strategy planning. Remember what we're talking about with this knowledge graph, validating outcomes. If I believe that releasing this feature is a good idea, I should have a data-driven case for that, right? And product managers are increasingly trying to learn data analyst and data scientist skills so that they can do their job in a more data-driven way. So we already have a lot of the tools as technical ICs in the data space to be really good strategists and product managers. All we need is sort of filling in the gaps around pricing strategy, go to market, monetization. I mean, all of these, everything from opportunity discovery all the way to go to market. We just need to fill in that gap. And so it's just as easy to upskill from a software or digital product manager to an AI product manager as it is to upskill from a technical IC, like a data analyst, data engineer, data scientist, into a data and AI product manager role. And what's really interesting is product managers are now the highest paid. I never saw this coming. Highest paid data role in the industry. Never saw that coming. I thought they would, at some point I would said, they'll probably be about the same as data scientists. They are now, there's multiple surveys that are showing they get paid better, which is kind of wild, right? Yeah, that was one of those, I could see demand, I said demand would equal out. I wasn't bold enough to say that they get paid the same.
my God, that's hilarious.
Oh yeah,
Okay.
and they're now getting paid better, which is kind of one of those. Sweet, I like it.
Yeah, well, I mean, because I've thought about making the hop myself, just because I just feel like I can improve upon some of the project management I've seen previously. I don't know.
Yeah, we have a lot of people who are product owners calling themselves product managers, and in the data science space, that's really dangerous.
Yeah.
I'll just light that match and leave it.
I was like, I'm not touching it.
Yeah, no, I wasn't expecting that one to be touched by anyone.
I'm gonna scan it. Yeah.
Yeah.
All right. Awesome. And so that is all the time that we have. Thank you so much, Vin. This was an awesome conversation.
Thanks for having me.
Feel like I learned so much. Thank you, everyone, for coming. I hope you enjoyed this episode as much as I did. And I look forward to seeing you again next week.
Thanks for having me.
Thank you.